Okay, so we've got conditional statements here as a review for our conditional statements. And the conditional statements, if you remember, we had the original statement, we had the hypothesis and the conclusion. The hypothesis was the if, the conclusion was the then, and then we had the converse, the inverse, and the contrapositive. So we're going to go through these conditional statements, undefined terms, and hopefully give you a good review. So the first one, which term represents a statement that is assumed true, and assumed means it can't be proven? We talked about this. What is a statement you can't prove? It is actually a postulate. If you remember, a postulate is a statement that cannot be proven. Okay? Theorems are things we can prove. Undefined terms are just undefined terms. And conjectures are things that we state based on what we've seen. We don't know if they're true or not, but ultimately sometimes you can prove them, sometimes you can't. But postulates are, they're also called axioms. That's a word you'll see as you get into upper level math. Those are things that just cannot be proven. Those are assumed to be true. Number 10, which terms are considered undefined terms in Euclidean geometry? Remember we talked about measuring, right? Undefined, we technically, that means can't be measured. Now, there was one exception. There was something that couldn't be measured that's not an undefined term, but we classified it as part of one of the undefined terms. It's already covered. And if you look at things that cannot be measured, point, line, and plane. Remember, a point is just an indescript location in space. We can't measure it, okay? A line is infinite. Can't measure it. Can't take a ruler and measure it. A point has no thickness, a line has no length, a plane goes infinitely in all directions. Why is it not a ray? Remember, a ray is a part of a line. Remember, we talked about that. The line takes care of that. That covers that. Why is it not an angle? Well, we can measure an angle. There's a 90-degree angle. There's a 50-degree angle. We can measure angles. Why is it not a segment? Well, you can measure a segment. A segment can be 3 inches, 5 inches, 6 inches. So these three, point, line, and plane, cannot be measured. And remember, don't fall for the one with ray. Ray is part of a line. That's already figured in there, okay? So now let's look at conditional statements. Now, so we're looking at logic here. All right. Well, actually, I think there's a little one here that I missed. It says, draw an example of the three listed above. I've got a fly attacking me right now, so he may make an appearance in the video. There's a point. Just got a capital letter. There's a line. And remember, a line can have as many points on it as you want, but you only name it with 2 points. And this could be, this is your symbol, line BC, line CB, however you want to do it. And then you also have planes. And remember, I told you, you can name a plane. Sometimes there's a capital cursive letter, so I could call this plane M. Or sometimes you have 3 points in that plane, and so you would call it plane PQR. Remember, there's 2 ways to name a plane. Okay, so now let's move on to conditionals. Okay, for conditionals, it says if 2 angles are complementary, then the sum of their angles is 90. Okay, which statement is the converse? Okay, guys, remember converse. The original statement is always, if P happens, then Q is going to happen, okay? That's the original. For the converse is, if Q happens, then P happens. So remember, for the converse, the if and then stay still, but you flip the hypothesis and conclusion. So let's look at the hypothesis and conclusion on this guy. All right. Hypothesis, 2 angles are complementary Conclusion, the sum of their angles is 90. So the converse should say, if the sum of their angles is 90, then they're complementary. So let's check it out. Two angles are complementary. This one says if two angles are not complementary, well, it changes the whole thing. That's not right. If two angles are not complementary, that's wrong again. We're not changing this to is and isn't and not and is and all that. It's basically all I want to do is flip the green and the pink. So it should say if the sum of their angles is 90, should be the first thing I see. Sum of two angles is 90. The sum of two angles, not 90. That's wrong, so it's got to be this one. And if you notice, this one says if the sum of two angles is 90, then the two angles are complementary. Do you see how I flipped for the converse? Okay, so let's look at the next one. If triangles are congruent, then they have equal corresponding angles. Okay, converse. Remember, converse, instead of saying if P, then Q, we're going to say if Q, then P. Okay? So what should go first? It should say if they have equals corresponding angles. It's not A. It's not B. Okay? And this one says if triangles have corresponding angles, and this is another misprint. Yay, we found another one. There's some mistakes on it. This should say equal. Okay. If the triangles have equal corresponding angles, then they are congruent. Okay. So this is the correct answer. This is where you flip the green and the pink. Remember, if and then stay still. And sorry for the misprint. Okay? All right, so let's go to the next one. Let's look at number 12. Number 12, move this over a little bit. Number 12 is asking you for the inverse, okay? Now remember, original statement is always if P happens, then Q happens. So now we're looking at the inverse. So what does the inverse mean? The inverse says, we don't change the order, it just goes if not P, then not Q. Remember, the inverse is if it says is, we change it to isn't, and if it says isn't, we change it to is, etc., etc. So all I'm looking at here is this says if two angles are complementary. For the inverse, what am I going to change that to? Are not complementary. Then the sum of their angles is 90. Then the sum of their angles is not 90. That's how we do the inverse. So look at the one that matches that. If two angles are not complementary, then their sum of their measures is not 90. Boom, A is your answer. This one says if the sum of two angles is 90. Well, these two, they're flipping the order around. We don't flip the order on these, okay? We don't flip the order. This one says if they're not complementary, but the sum of their angles still is 90. Remember, it flips it. This says if they are, it is. So our change is if it's not, it's not. Okay? So let's look at the next one. Same thing. We have the original conditional statement is always if P happens, then Q happens. And for this, we're looking for the inverse, okay? And this should say inverse, not converse. Apologies for that. So the inverse is if not P, then not Q. So let's look at the original statement. If you look at the original statement, it says if triangles are congruent, so we're going to change that to are not congruent. they have equal corresponding, then they don't have equal. So I'm looking for this statement down here. Well, first of all, you can cross off the ones where they flip. Triangle congruence comes first, corresponding angles second. So anything with corresponding angles first is out. That helps you right there. If triangles are not congruent, then they do not have corresponding angles. So that's the inverse. So remember, converse, you flip them. The if and then stay still, you just flip the statements, the hypothesis and conclusion. Inverse, you don't flip them, you just inverse it. If it says they are, the inverse says they aren't. If the original statement says they don't, then the inverse says they do. Okay? All right, contrapositive. So let's look at the contrapositive. Again, the original statement is if P, then Q, okay? Remember, the converse was if Q, then P. The inverse is if not P, then not Q. And the contrapositive is if not Q, then not P. What do you notice? Not only are we inversing it by putting the not in there, but we also flip it. So the contrapositive is a combination of the converse and the inverse. So instead of me saying, I'm going to go ahead and color code these again. If two lines are parallel, then they have the same slope. You're going to inverse it and you're going to converse it. Well, let's converse it first. Let's flip it around. So if I flip it around, it's going to say, I'm going to go and flip it around here for you. If they have the same slope, then two lines are parallel. That's the converse, okay? All I did was I flipped the hypothesis and conclusion, okay? That's the converse. In order to get the contrapositive, we have to take the converse and we have to apply the inverse to it. So now, if they don't have the same slope, then two lines are not. So I've conversed it and inversed it. So if they don't have the same slope, then two lines are not parallel. There's your answer. And that's how you do the contrapositive. Contrapositive's kind of tricky because it does employ two structural changes. Okay? It does employ two structural changes. So let's do one more contrapositive. Remember, the inverse, or the original, is always if P, then Q,